So we've talked about the three-dimensional equation of motion. We looked at the horizontal equation of motion by ignoring any kind of vertical forces. And now it's time to talk about the vertical equation of motion, which comes from the three-dimensional equation of motion. So what we're going to do in the vertical equation of motion, this governs air that's going up or down, tells us how it's accelerating. We're going to throw out Coriolis force. Coriolis force does act on things that are moving up and down, like rockets or spaceships, but we're going to assume that that's a small, very small. And then also, we're going to eliminate friction. There's not much friction of the air that's going up or down. So that leaves us with a few terms. We have the acceleration term, we've got the pressure gradient term, and then we've got the gravity term. These all act in the vertical. So when we talk about acceleration of wind in the vertical, we're going to take our three-dimensional wind vector and look at only one component, and that's the component that is up and down. That's your W component, and we'll see how W is accelerated. So there's your acceleration term. So acceleration is now just the change in W with time. So in other words, how is W, the up and down wind, accelerating? Is it accelerating upwards or downwards? Our next term is the pressure gradient term. So in this term, we are only looking at the pressure gradient that is directed in the z direction. In other words, the pressure, how does pressure change as you go up or as you go down? And it seems pretty obvious that as you go up, pressure decreases. That's how simple the pressure gradient term is in the vertical equation of motion. And actually, we've seen this before. Gravity is also acting on vertical motion. So we've got two terms, and when they're not in balance, we have accelerations. But you know, most times they are in balance, and that means that there's no acceleration. So if those two terms are in balance, if the pressure gradient is balanced by gravity, then there's no vertical acceleration, and we call that a hydrostatic atmosphere. And remember, we talked about this already. This is your hydrostatic assumption. And this is where the hydrostatic assumption comes from. The assumption, which is very important, meaning that you'll probably have an exam question on this, the hydrostatic assumption is that the vertical pressure gradient is balanced by gravity. So we've seen this before. Does this mean that there's no vertical motions in a hydrostatic atmosphere? And the answer is no. It means you can't have vertical accelerations, but if the air is already moving, that's okay. It doesn't say there can't be motions, it just says that there can't be accelerations. Sometimes the hydrostatic assumption breaks down. Wherever you have big accelerations, then the atmosphere is non-hydrostatic. And some places where you have big accelerations are in thunderstorms and also in mountain waves.